In the diagram, G, A, M, and E are the vertices of kite game. G, M, and AE, the diagonals of game, intersect at P. Determine A, the coordinates of G, B, the gradient of AE, and C, the value of B. Let's start with part A. Determine the coordinates of G. Now, one of the most important characteristics of a kite is that the longer diagonals bisect the shorter ones. This means that P is the midpoint of the diagonal GM, and we can use the midpoint formula to find the coordinates of G. Let's start with the x-coordinate, and we can say the x-coordinate of P, let's call it Px, is equal to the x-coordinate of G plus the x-coordinate of M all over 2. The x-coordinate of P is -2, is equal to the x-coordinate of G, the coordinate we're trying to find, okay, Gx, plus 1 all over 2. Now we can multiply both sides by 2, and we get -4 is equal to Gx plus 1. Now we can subtract 1 from both sides, and we see that -5 is equal to the x-coordinate of G. Now we can find the y-coordinate. We can say the y-coordinate of midpoint P, let's call it Py, is equal to the y-coordinate of G, Gy, plus the y-coordinate of M, My, all over 2. The y-coordinate of P is 6, and we make this equal to the y-coordinate of G, it's the value we're trying to find, so we say Gy, plus the y-coordinate of M, 4, all over 2. Now we can multiply both sides by 2, and we see that 12 is equal to the y-coordinate of G plus 4. Let's subtract 4 from both sides, and we see that 8 is the y-coordinate of G. Now G has got an x-coordinate of -5 and a y-coordinate of 8, and we can write our answer down here. Let's write the coordinates of G on our diagram as well, and now we can move on to part B. Determine the gradient of AE. Another important characteristic of a kite is that the diagonals are perpendicular. So let's draw a right angle on our diagram over here. This means that AE is perpendicular to GM. So let's use the gradient formula to find the gradient of GM. Let's say that G is our first point and M is our second. Now we can say the gradient M of GM is equal to the y-coordinates 4 minus 8 over the x-coordinates 1 minus -5, which becomes 1 plus 5. 4 minus 8 gives us -4 over 1 plus 5, which is 6. Now we can simplify our fraction. 4 and 6 are divisible by 2, and we get -2 over 3. Now to find the perpendicular gradient, we need to find the negative reciprocal value. So we can say the gradient of AE is equal to, we have -2 over 3, it's our new fraction positive. Let's take 2 over 3, flip it, and we get 3 over 2. And finally, we can move on to part C. Determine the value of coordinate B. B is the x-coordinate of point A. And because we already have the gradient of AE, we can use the gradient formula to find the value of B. Now, we don't have the coordinates of point E, but point P lies on line AE, which means that these points are collinear and therefore have the same gradient. In part B, we have just found the gradient of AE is 3 over 2. If points APE are collinear, then AP has the same gradient. And we can make a note of this over here. The gradient of AP is also 3 over 2. Now we have the gradient of AP, the coordinates of P, and the y-coordinate of A. And we can use this information to find the value of B. So let's say that P is our first point and A is our second. So now we can say the gradient, 3 over 2, is equal to 12 minus 6 all over B minus negative 2. We need to solve for B. So let's multiply out our common denominators. And we say 3 multiplied by B plus 2 is equal to 12 minus 6, which is 6, multiplied by the denominator of 2. Now on the left, 3 multiplied by B gives us 3B. 3 multiplied by 2 gives us 6. Is equal to 6 multiplied by 2, which is 12. Now let's get 3B by itself. So we can say 3B is equal to, let's move the 6 to the right, which means we subtract 6. 12 minus 6 gives us 6. And finally, to get B by itself, we divide both sides by 3. And we see that B is equal to 2. And we have now completed this question.